Right, in this short video I'm going to show you how a dimmer switch works. Just a regular dimmer switch used to lower the brightness on a light or to turn it up again. Anyway, key piece of kit here is one of these. The old-fashioned name is a rheostat. You're probably more likely to know it as a variable resistor. Quite simple the way it works. We have a long coil of many turns. Now the amount of turns that the current has to pass through determines the resistance of the rheostat. So at the moment the current will go in here, it will go through these turns and then up and out, so that's half resistance. Okay, if we had it down here, the current would go in, it would have to go through all of these turns before it came out, so that would be a high resistance. Conversely, if we have this slider down the other end, the current goes in, only goes through this section before it can escape down this bar here, so that would be a low resistance. So there we have it, that's your basic variable resistor. Now we can use that in series with a regular filament bulb to get it to work pretty similar to a dimmer switch. So high resistance means low current, means the bulb is off. But if we take the resistance down, then the bulb comes on. So the resistance is right down, so the current is very high in the series circuit, so the bulb is on. Okay? However, this is not the way variable resistors are used in dimmer switches. They're actually used a slightly different way. They are used as a potential divider. Now, if you've ever wondered why variable resistors, and especially rheostats, have not 2 but 3 connections, this should answer it. Okay? Now this is just your fixed resistance, this is the total resistance. Now if we can split it into this part and this part, we have a potential divider. Okay, let's see that in action. So basically, your bulb comes out. Now the bulb is not in series with the variable resistor now. The full resistance is in parallel with the power supply. However, the bulb goes in parallel with this section. Okay. Right. Now hopefully you can see there that the bulb here is now in parallel with this section of the variable resistor, with this section of the coil. Okay. Now if we have it down here, the resistance of this section and therefore the potential difference across this section is low. Remember, this is now a potential divider where you've got the potential difference across this bit plus the potential difference across this bit equaling 9.69 volts. Okay? But the potential difference here is low, so the potential difference across the bulb is low because the bulb is in parallel with this bit. So just to recap, the light bulb is in parallel with this section of the coil. Okay, so this is like our V2, this is our V2 output. At the moment we've only got the half resistance, so we've got half the potential difference of the VT. Okay, so down here, small resistance, small share of this. Now if we take it up, okay, don't forget the bulb is in parallel with this section. As we take it up, resistance increases until the potential difference here becomes high enough to turn the bulb on. Okay? So high resistance, high potential difference, high current through the bulb. Now that is actually exactly how dimmer switches are set up. The reason I'll go into in the next video.